Hi, welcome to Phase 4's video demonstration and tutorial on a revolutionary MICROT data logger that is ideal for composite material fabrication monitoring. We've leveraged our RFID expertise to develop a data logger that is extremely thin and small and can communicate through composite materials and be embedded in composite materials to monitor the fabrication process. We're wireless sensor experts. We're not composite material experts, but we've had such a great response from the THIN MICROT data logger that we wanted to share a video that shows how well they work. What we've done is RFID wireless technology uses no battery power to communicate from the data logger to the reader and then to the computer. That means since we're using no battery power for the wireless communication, we can use a very small battery. And that allows us to make a very thin data logger that has a very small thermal mass and has very little impact on the structure if the MICROT is embedded as the resin is curing or as the structure goes into an autoclave. The other thing that makes the MICROT a great fit is its ability to operate at high temperatures, which is what happens when the resin goes exothermic in a composite material reaction. The MICROT is rated up to 145 degrees Celsius or 295 degrees Fahrenheit and has a number of very unique features which you can see on our webpage. Also, you can order a demonstration kit with the MICROT that comes with everything you need. We also do lots of custom versions of the THIN MICROT for many different clients. And if you want to see some more detailed information and the specifications on the MICROT, just click on the link and the full description of all the functionality of the MICROT is listed on our website. What makes the MICROT so unique is its really small size. It's less than 2/10 of an inch thick, and it is very small. We have the battery module here, the electronics and antenna here, and the other feature that we've added is we've put the temperature sensor on the very end of this small cable. And the reason we've done that is that gets the thermal mass of the rest of the sensor away from the actual temperature sensing element and gives you a very high response, fast responding temperature sensor. The temperature sensor that's in here that's coated with a light coating of epoxy is less than 1 millimeter square and is very responsive and provides accurate and responsive measurements of the curing of the resin during the composite manufacturing process. All right, now we're ready to do our demonstration where we're actually going to embed our MICROT data logger into a fiberglass structure. But let's talk about our setup real quickly. I have a standard Windows laptop computer. It's connected to a standard RFID reader that comes with the demonstration kit. And it's then connected to a little antenna module that will talk to the MICROT data logger. So what I'm going to do is place the MICROT data logger on the reader, and then I'm going to fire up the software and start communicating with the data logger and configuring it. The MICROT software is really easy to use. It connects to the RFID reader and then wirelessly to the MICROT. I've got it started up here, and let me show you how easy it is to use. First, we click Find Loggers, and it says it's found the tag, and that's the unique serial number for this particular THIN MICROT. Now we go over here and click Read Logger Information, and that fills out all of this information on the data logger. We have a green battery voltage. There's more in-depth videos on our site. I'm not going to go into all of the different features, but just enough to do the demonstration today. See our other videos for a more in-depth demonstration. But right here, I'm going to change the logging interval to every 10 seconds. The data logger can hold 3,902 readings, so that should be plenty to monitor the curing of our fiberglass structure that we're going to make. And now I simply press Start Logging, and it's going to communicate with the MICROT and download the readings. And as you can see right now, we have started the logging right here. The status is logging. We're going to take our MICROT data logger, we're going to go outside, and we are going to embed our MICROT data logger in a fiberglass structure and monitor the heating as the resin cures. All right, we've moved outside so we can mix up our fiberglass resin, and we're going to embed our MICROT between 2 layers of fiberglass cloth. So the value of the thin MICROT is that it can be embedded between layers of composite materials such as fiberglass. So we're going to do that right here in this little container. I've shortened up the tether a little bit so it will fit in there. We're going to drop in a bottom layer of fiberglass cloth, drop in the MICROT, drop in the top layer, and now the data logger is already logging. We started it earlier in the video, and we're going to mix up our fiberglass resin next and activate it and let it start curing. Okay, we've activated the fiberglass resin and we're finishing stirring it, and now we're going to pour it in. Now it's a hot day out here today at phase 4, so we'll probably see a change in the data logger in temperature when we walked outside, and then we'll probably see it jump a lot here. This resin has an activation time of about 5 minutes, and we've been here for I've stirred it probably 2 or 3 minutes, so we'll probably have a little bit of a delay before the resin goes exothermic. I'm going to pour a little bit more on there. And when we come back, we will have a hardened structure, and we'll be able to download the data from the reaction while the MICROT is still embedded in the fiberglass. All right, we're ready to download our MICROT data logger that has been cast in fiberglass. We'll pull it out of the container, and there it is right there. We are going to place it on the reader and do find loggers, and there is the serial number, and it found the tag. Now we're going to read the logger information, and that's going to come up showing we took 602 samples, and out of 3,900 available. And now we'll download the log. This screen comes up and asks us where we want to save the file. We already took a look at this file, so we're going to download it again. And there's the data in tabular form, but here is the graph of the data. And when we first saw this, it was kind of interesting. We saw some things we didn't expect, but here's what we sorted out from this data. This is the part of the video where we started the data logger and we were in the conference room. Then we went outside, and today it's a very hot day in Boulder, Colorado. We set the MICROT data logger on a hot table in the direct sunlight, and that's what you see right here. Then we poured the liquid fiberglass resin in, and then it warmed up, and then it was at the time before it started going exothermic here. Then when exothermic, you can clearly see where that happened, and then slowly cooled down back to outdoor temperature. And then here's where we brought it back inside to the conference room to shoot this video. So you can see that the value of being able to characterize inside of the composite material exactly the type of ramp and time that's going on in the reaction. And the other thing is, in the little demonstration that we did it out on the sun on a cardboard or on a card table. But if this were a continuous flow oven where the composite material was traveling into, you can attach wires to this, and most wireless sensors aren't small enough to be effective. So this gives people doing composite material manufacturing the ability to get an exact temperature profile as it goes through a continuous heating oven, or the same is true as with an autoclave that is typically will pull a vacuum and also heat up the whole assembly. So we hope this provides some insight into the unique characteristics of the THIN MICROT data logger and how it might be very valuable as a new tool in the composite manufacturing industry. Thanks for watching our video.